In this video, we're going to look at a question on capacitors. Now, this question is designed to throw you off. It's an unfamiliar situation. It's probable that you wouldn't get tested on this in AQA or OCR because this is not specifically mentioned on the syllabus, and this question does sort of require you to know what this is, but it's a really good challenge anyway. So read through this question carefully, really consider what this arrangement is doing, and then answer all parts of the question. So this is a bridge rectifier, and it does a very important job. So it changes AC current into a DC output. If I was to put, say, a voltmeter there, I would get a DC output. So how does it work? When the current flows this way, it gets blocked by this diode, which is connected in reverse, but it can get through this diode, blocked by this diode, comes out here. When the current goes the other direction, it will travel this way around. It gets blocked here, but it can go through this diode, gets blocked here, and then will obviously travel this way. So whichever way the current goes, it always ends up at the top. So it's turning AC into DC. And then the capacitor smooths this. So if we have an AC trace, we would expect the current to do this. If we purely turned it into DC, like I've just explained, you would get the current or the PD doing this. But a capacitor, because it charges up and then discharges slowly, it will smooth out that drop so that it will never quite go back to zero. And depending on the value of capacitor that you pick, you could smooth it and you can get something that is very, very, very close to DC. So you don't really need to know most of that to answer this question, but it's always good to know. So what is the peak voltage? Well, the peak voltage is the maximum voltage, so we just read off the graph. The RMS voltage, so RMS is what is the average value of the voltage over a cycle. So RMS is the peak divided by root 2. So put that in your calculator and you get 2.8 volts. Again, neither of these actually needed any of this knowledge. The frequency. This is probably the first part where it maybe does require this knowledge, because you might think, well, frequency is 1 over time period. So the time period, well, I start here, one cycle goes to here, but that is not a full cycle. That is only the positive part of the cycle. We also need the negative part of the cycle as well. So this is 1, this is 2 here. So the time period is 20 milliseconds. So 1 over 20 milliseconds gives us a frequency of 50 Hertz. Part B. Determine the change in potential difference for a single discharge of the capacitor. So a single discharge, if we start here, a single discharge goes to here. So we started at 4 and we end at 2.4. So that is 1.6 volts. So again, really easy, doesn't actually require any knowledge of what this is. So again, if you can keep you calm, you can answer a lot of questions even if you're not sure about something in the question. Determine the change in charge on each plate of the capacitor. Well, we know that charge, or change in charge, is C times by the change in potential difference. So our capacitance is 5 times 10 to the minus 6 farads, and our change in PD is 1.6 volts. So again, put that in your calculator and you get 8 times 10 to the minus 6 coulombs, or you could say 8 microcoulombs, either. Well, on the answer line it's C, but you would be entitled to write micro as well. Show that the average current in the resistor is this. Well, current is the rate of flow of charge, or change in charge over change in time. So we know that the change in charge is 8 times 10 to the minus 6 coulombs, because we just worked it out here. And what time does that happen? in, well, we're talking about discharging. So we're talking about this time to this time. So that's 7 milliseconds, so 7 times 10 to the minus 3 seconds. Put that on your calculator and you get 1.14 times 10 to the minus 3 amps, which is 1.1 times 10 to the minus 3 amps to 2 SF. One final part of the question. Pause the video now, quickly try this. We want to estimate the resistance. So resistance is defined as V over I. So the potential difference is, what is the potential difference? Well, we can't quite use any of these. We need to know the average PD, because the PD starts here and decreases to this. So it starts at 4, ends at 2.4. So the average is obviously that, which is 3.2. And then we're going to divide by our value of current that we just worked out and plug all that in. And it gives us 2,900 ohms.